Breaking the login barrier. Unified proof of constant time file management via size-based slot allocation, SBSA. Aaron Cattell. April 2025. Abstract. Traditional data structures, such as balanced trees and skip lists, impose an inherent O-login complexity for ordered file operations. The size-based slot allocation, SBSA, model introduces an alternative by deterministically mapping fixed-size classes to unique slots, achieving constant time complexity. This document unifies the SBSA model and its infinite capacity extension via file thickness, presents pseudocode, a performance comparison, and a formal proof of countable infinity in the extended model. Introduction. Most ordered file management systems rely on comparison-based structures, resulting in logarithmic time complexities. The SBSA model departs from this by employing static mappings based on file size classes. By removing dynamic reordering, it achieves O(1) operations under known size constraints. Further, a logical extension introduces the notion of file thickness, enabling countably infinite virtual capacity while maintaining deterministic mapping. The SBSA model. 2.1 Model definition. Let S equals S1, S2, Sk be a finite set of predefined size classes. Each file of size psi is deterministically mapped to a unique slot pi via a function. F of psi equals pi. Only one file may occupy a slot at any given time. 2.2 Assumptions. Size classes S are finite and known in advance. N-to-1 mapping exists between size classes and slots. Slots are pre-allocated in memory or storage. 1. 2.3 Pseudocode. Algorithm 1 Insert file. 1. Procedure insert file, file 2. 3. 4. 5. 6. 7. 8. Size class determine class, file.size. Slot lookup slot, size class. If slot is empty, then place file in slot. Else return error or retry. End if 9, end procedure. Algorithm 2 Delete file. 1. Procedure delete file, file 2. 3. 4. Size class determine class, file.size. Slot lookup slot, size class. Clear slot 5, end procedure. Infinite logical extension, file thickness. 3.1 Extended model. To address finite physical slot limitations, we introduce a new dimension, file thickness, T-set membership symbol n. AFILE is now defined as a triple SAD smiley S, P, T. The extended mapping becomes FS-T equals FS-T. This allows infinite virtual capacity over a finite physical slot set. 3.2 Theorem, countably infinite capacity. Theorem, given a finite set of size class slots P, and an unbounded thickness index T-set membership symbol n, the set of virtual slots P times n is countably infinite. Proof. Let each physical slot P set membership symbol P be extended as TP equals the P, T, T set membership symbol n. Then TP equals P times n. P set membership symbol P. Since P, infinity, and n is countably infinite, the Cartesian product P times n is also countably infinite. Thus, the logical space is infinite despite finite physical allocation. 2. Performance comparison. Operation. B-tree skip list hash table SBSA. Insert O login. Delete. Search. Order maintained. Supports dynamic sizes. Worst case. O login. Yes. 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 O login. O1 average. O1 average. O1 average. No. Yes. O1. 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 Yes. No. ON. Simulation, SSD file storage. 5.1 parameters. Size classes, 1 kilobyte, 2 kilobytes, 4 kilobytes, 64 kilobytes. Slots, 100,000. File events, 1 million, exponential distribution favoring smaller sizes. 5.2 comparison. B-tree, 1 million times log 2, 100,000, almost equal to 17 million steps. SBSA, 1 million times 1 is equal to 1 million steps. Speedup equals 17 million. 1, 0, 0, 0, 0, 0, 0 equals 17 times. Historical context. O1. Ordered file systems evolved from early tape-based sorting to AVL and B-trees in the 1970s, then skip lists in the 1980s. SBSA breaks from these by externalizing order into the classification scheme, paving the way for more predictable and scalable architectures. Conclusion. The SBSA model redefines ordered storage through static slot allocation, eliminating the comparison bottleneck, and achieving constant time complexity. The file thickness extension provides theoretically infinite logical capacity, supported by a provable mathematical foundation. SBSA is especially effective in contexts demanding deterministic latency and performance stability. 3.